Yeah, so my name is Shafran. I work at Flow, but this talk could be about a bit different experience. I've been working with WebRTC for 5 years, so have something to share. We won't go too deep into it, but it will be interesting, I think, to see how it works and how it's different from Android, although it was also for Android. Yeah, so let's start. Oh. So yeah, the calls are important. Of course, there are some narrow use cases like messengers, of course, but there are other use cases where we can use them, like education, privacy, even telemedicine. So sometimes it makes sense to build them inside, not use other providers of calls. People talk, yeah, that's the idea. But we also have a group calls with friends. We have some meetings in a company, yeah, when we discuss something, KPIs, doing the work, sprints, so on. Sometimes we want to have big picnics. It's a bit challenging to do this inside calls, and usually it's broadcasts. But it may be a good idea to have this to make people more interactable, like to ask questions, what's happening. But it's also not so very interesting, so we are gonna go for the unlimited calls. Like, let's join everyone. Why not? It's maybe possible. We will see today. Our plan for today is to learn a bit about WebRTC because it's a bit different from what we usually use on Android. It's to talk about one-to-one calls, what we can do there, what features. We're gonna take a quick peek there. And we talk about a lot about group calls with many people, of course. So let's start with WebRTC a bit, how these things are working. What it is. So it's about communications, yeah, on web, and mostly it's used for calls, but you can also build other platforms, video streaming, other things. But we're going to talk about calls, of course. It also has SDKs for Android, iOS, native clients. You can put it inside your, robot cleaner and have a call with them. So it's very broad. It's already inside our web browsers. So if you want to create MVP calls on web browser, it's really easy. Just a bunch of lines of code and it's just working. It's good that it's open source, so it's free, and you can adjust it. You can fork it and change it on mobile platforms. That is some pro level, but it may be really useful. So let's see how it's working. Let's imagine I have my macOS, like my laptop, and I want to call to the Android. Yeah. So we can see that inside call application we need to insert WebRTC SDK, but in browsers it's a bit separate layer. So we just need to write code for like our page there. Let's imagine I'm inside social network call. I want to call to my friend. I will ask API server, please make call to the guy I know with some ID. Then we will push messages through Firebase from Apple, push notifications, and he will answer. This is signaling server. It's a bit different story. It's specific to WebRTC, but it's pretty easy. It's used to connect between devices. Usually we use WebSockets because it's really convenient. You can accept messages, you can send messages. So here we use the signaling server for sharing metadata and for having the first conversation, like what video or audio codecs we have on different devices. Because if my Android doesn't support some new video codec, we can't use it. We need to have some common ground. If everything goes well, we connect. We may connect even like P2P between two devices. It's really cheap because we don't need any media servers. But sometimes we have restrictive Wi-Fi networks, and they doesn't allow this kind of connection. So we may use relay server. Basically, it just accepts packets and resends. But because it's like third party, it's okay for Wi-Fi networks usually. Another stuff is group calls. We need some middle layer, so it's usually media servers. It's kind of obvious, yeah, but yeah, that's the point here. I know it might be a bit intensive, but don't worry, it won't be like too deep into this, but the main like structure, how it works, and we will use it a bit later. So the main idea is here, it's really good framework for communications. We can have like browser supported, we have SDKs, it's pretty good. And but it's like peer-to-peer first, so you don't have big group calls like from the scratch. You need to build it. And usually on the WebRTC side, you already have like audio codecs, video, things about connections. And our client side, you have logic of the signaling server, for example, with metadata. You have some API like to connect between devices. The next part is about one-to-one calls. We're gonna see some features that can be implemented because from the basically we're gonna talk about audio, video, AR effects because it's boring to have calls without AR effects now, and we're gonna talk a bit about screen sharing also. So. First thing first, it's audio because it's more important. How it works, I think it's interesting. So we have a lot of things going on behind scenes. So first thing is echo cancellation. We don't want to hear ourselves like when we don't use headsets. If we like play audio, it might be getting back inside microphone. So this fixes this. We also have automatic gain control. It manages the audio level. If you speak too loud or too quiet, it will help. Another problem like that can be solved is like voice activity detection. It helps to understand if you are talking or it's just something noise, so we can save something on not sending packets, for example. And the last thing is usually noise suppression. It helps to reduce the noise and make like have pure audio calls. It works from the like WebRTC already, but it's quite I don't know standard, so it can be better because they use some standard algorithms and that's it. So now we have AI, ML things, so they're quite good, and we can try to use them also. There's some reference number that you can achieve. So, for example, there are problems like slow and fast audio segments when you need to keep up with the voice and just playing things fast or slow. So this custom noise suppressor that you may implement may help. And you also can reduce network load. So for Android, we will use TensorFlow. And how it can be done, it's like having the fork of WebRTC framework, using TensorFlow just there, and our client here a bit above. So there is a class basically that receives audio packets, and we may exchange with TensorFlow these audio buffers and put them back. To download like ML model, we can use some API server with these files, because otherwise our APK would be too big. But the problem with calls in general that they burn a lot of CPU. It's really heavy, so adding like noise suppressor additionally, like custom, may cost you a lot. So you need to implement at least a fallback to the standard algorithm if we have some low-end device. Yeah. And in general, you need to be really careful if you try to push some feature like this. But on the other side, it may be beneficial. So here, what we can have, we can increase audio quality, we can reduce server load by this, and we can unify experience. But to be honest, on iOS, noise suppressor is too good, so we don't have to do this. but on Android we have a lot of different vendors, so it makes sense. Let's talk about video. Here, one-to-one calls, the main challenge is battery, as I was already talking, and the network load, because you need to send frames, it's really heavy. And there's also challenges with screen sharing, like, you know, this, can you see my screen, why it's so blurry, so it's always a pain. The main idea of working with video codecs into like cutting our video into frames, but not all frames have the full picture. Some frames, like most of them, they have only difference between like current frame and previous. So you don't need to send like the whole image. You just push in some divs, and that saves the main problems. So we have here trade-offs between CPU and battery, because there are some new codecs, but they mostly work on software layer. We don't have them like on hardware layer. That's the problem. So for example, let's discuss one old one. It's like on the left part, and the VP9. They look almost the same, but there is a problem with quality drop on the left part. So what we can do, we can like have a pixelated video if we use just the left one. Although it's pretty fast and it's like good and works almost on all devices, we may have problems with this. On the other side, the device load will be higher with VP9, so we can't just use it every time. We need to make some trade-offs here. So what we can do is just basically divide our, so you can cook some meals on your phone when you use VP9. So what we're gonna do is we're gonna use the older codec when we have enough bitrate, and we're gonna use VP9 when we like have some network connectivity problems. So we may compress video better, but we will use a bit of more CPU. So that's the way. With the screen sharing, there are also like many problems. Like the main problem for me is this, like, what's happening? Can you see my thing? Why? So there are really simple answer to that. There are some hints to the WebRTC that we may give, like just, hey man, just maintain resolution WebRTC, please. Also, there is a hint, like there is a text here. To be honest, it doesn't work, but at least you're trying, and that's what matters. So that helps in most cases, yeah, but still it's not ideal, but that's something to start from. Other thing that we can do is, so summary for this part, we may adapt bitrate, we may experiment with codecs a lot, because new ones are beneficial, but they still don't have hardware support on most devices. About AR effects, like, it's really boring to have calls without AR effects, to be honest. We want to hide some background, we want to, I don't know, have some face masks, and maybe even beauty fields. I don't know, if you like feel in bad mood and I don't want to wash, just, I don't know, have some mask here. So I won't go too deep there. Basically, there is a class where you can take frames from and put them back. So you use these classes and you modify them. The hardest part is like how to modify them. There are a library called MLKit. There is, and it has already some free model networks that work on the device offline, so you can reuse them. And for iOS, there are other actually, but you can like use MLKit on iOS, but they have some native also. So basically the screen from MLKit web page, so you can use it to make like background changes. You can find points on your face, so you can make some masks from it. That's an easy way. So I wouldn't say it's not that hard, but it's possible, and your calls would be much more interesting to use if you have AR effects. Okay, let's call it a bit about system API, like how our calls interact with Android, iOS. So basically on iOS you must use CallKit. That's it. On Android you have options. You may use connection service or you may not. Yeah, and these things are important if you want to use your calls with other applications. So, for example, if I'm calling in one application and someone others calling me from different one, we want to make sure that we don't talk on the same time. So these things help. It also may introduce your calls into the default application on your phone. Yeah, the thing is, it's a bit tricky on Android, so you need to be careful, but it's just some warning, as always. Let's talk a bit about audio output management. I'm not gonna go too deep, but basically, yeah, you need to detect devices and to switch between them. And usually we have these options. It's like speaker, loudspeaker, wired headset, and Bluetooth. And the last one is the most painful to deal with. So the first two are always presented, so that's easy. The second one is also easy. Just ask GPT to make code for you. Here it's tricky. If you ask it, it will do, but it will be something like this. It's like all the way using Bluetooth profile, some broadcast, but there is actually new API, our device callback, and the main benefit of it, you don't need to use Bluetooth permission, and it's also kind of better. For example, I have my watches, and with previous API, it was always answering my calls on, I don't know, phone, but I don't need it. But the second one works better, and it understands it's phone. We don't need to answer on phone if I have my watch. Sorry. Okay. Another problem, if you just I don't know, looking at something and you're answering, you may notice it works for you, but if you don't think about it, there is actually a problem. If your screen is turned on, you can touch something accidentally by ear, and I don't know, do something order food accidentally. So actually on every device, it might be not that obvious, we have this proximity sensor that actually tries to estimate how far away you're from the phone. Usually it's kind of like yes or no. Sometimes it may give you some numbers, but it's really estimations. To use this, we just again use some code. That's so yeah, operation system helps us with code, but we need to be careful how we use it, because there are some tricky points, especially with connection service on Android. And yeah, so let's talk a bit more about architectural side of the calls. When we have group calls, it's really different. It's not like one-to-one. We need to care more about load and CPU and so on. So from the out of the box, they don't work well. So we need to optimize things. We need to optimize audio, video, network, and UI. Yeah. So let's start from audio. What we can do here. From the beginning, we have one output audio channel. That's obvious. We need to talk and send data. When we have one calls with two people, we receive two audio channels. But then the problem, if we have yeah. So when we have let's just go. Yeah, when we have 100 people, we would have 100 audio channels. When we have more, unlimited, that would be a real problem. So yeah, and again, everything is taken. So what we can do is basically offload a work to the server, as usual. Yeah, that's how we do. So we will use media server, and we will mix everything on this side, and we will just receive one incoming audio channel, which is really cool because you don't depend on the number of people that you have in the call. And how it works, usually server just mix every audio channel, but when sending back, it subtracts your audio channel. So you receive only other voices and you don't hear yourself. You also need to receive the list of who is talking right now, who is disconnected, because when you had all audio channels on your client, you may check the levels, yeah. But now only server knows who is talking. That's some challenges, yeah. So that's an easy way to offload work, but there are some things you need to care, like who is speaking. It's a bit different now, and you depend much more on the server side. Video has similar problems, yeah, because it requires many resources, but we only need to see people who are on your screen. You don't need to see all people because they are just on the other pages. And we also have pretty good cameras right now, the front camera, but we don't need to see the full HD because they're just small square there. So how to fix this? We may again offload many work to server and ask him, please just send me these videos and in these sizes. So the all work would be there. That's easy way to do it. I mean, it's not easy for them, it's easy for us, of course. That's the idea, actually. And for example, if we update our layout, for example, we have one prime speaker now, we just update what we are requesting from the server. Now let's talk a bit about video tracks again. So here it's a bit different. We still need to receive some video channels because we have some people. We can do this again on the server side, but that would be not very flexible if you just put all videos into one. Yeah, it's kind of not very useful, to see all people. Yeah, the problem here, again, we have video tracks for each user. Every time someone goes inside the call, we need to renegotiate the contract, what video he may support and so on. That's a little pain. So again, we have video tracks for everyone. Yeah. Let's assume how it's working. We may just say, please WebRTC, we only have 10 people, I swear to you, yeah, but actually we have many of them. And we kind of trick in WebRTC into thinking that we have only 10 people. And now we need to manage how we're going to deliver frames. So usually we deliver a frame first person to the first video track. But now we are using them. So we just fixed that we only have 10 video tracks. And when someone comes on your screen, for example, user number 7, we would update to the server what we see on the screen, this JSON. So now he will start sending frames for the 7 person to the first video track. And on every frame, we would have ID of this user. So on the UI side, we would map these frames to the needed video views. That's how it's working. Yeah, and what about sending video? If we sit in really big call, probably nobody even watches our video. Why we should send it? Yeah, we can of course disable it, but it's not fair. So the idea here, if the call is really big, we may detect that we don't we're not the main hero, so we just may show video to ourselves. If that's easy, you don't need to send it anywhere, and just stop sending frames. And when someone requests your video on the screen, you just receive update from server side. So yeah, the idea, we ask for what we're gonna see on the screen from the server, We fix video tracks numbers, the trick here. And we do not send if nobody watches us. Why? A bit about networks, really small things. You can, for example, update your JSON protocol to message pack. It's binary format. When the call is really big, you have a lot of messages going on in the signaling side. Again, in the server, like intermediate. And for example, if someone raises the hand, yeah, we send some command like to the server. Somebody send the hand, and all people receive changes. So we will really save a lot when we move to the binary format. Other thing is just simple, like we remove all defaults from JSONs or from this message pack now, because why we would be sending them? That's some obvious ideas. And you need to check on the WebSocket implementation, like that you use, that it has this parameter called deflate. It just basically compares with the messages. So on the network side, it's just really small things. The main benefit was from reducing audio and video, because like the video is the biggest part here and the biggest problem. Yeah, let's just summarize it and have some more pizza, maybe, or drinks. So WebRTC is great, but it's mainly for one-to-one calls. So when you want to improve it, yeah, for one-to-one calls you may add some extra features. For group calls we need to optimize a lot. Yeah, we need to improve some. Yeah, that's optional thing that we can do. And for bigger calls, it's we can fix one audio track, we can fix several video tracks that you may see on the screen, and that's it. So yeah, many thanks.